Dear viewers, in this lecture, we will see how information propagates and how we can represent them graphically. In this world, there are many people who are using various social media networks. For example, Twitter had 330 million monthly active users as of 2019, Facebook had 2.50 billion monthly active users as of 2019, and YouTube had around 2 billion monthly active users as of 2019. All of these users have user accounts in the corresponding media, and almost all the users are somehow connected to each other. Let's talk about these types of connection. How are the Facebook users actually connect each other, connect themselves? Now, most of the Facebook users are connected by being in a friend list. When people are in each other's friend list, they can see each other's update and they can interact with each other. This connection works a bit differently in Twitter. Here, people actually follow each other to get connected and see each other's update. Now, these updates in Twitter are known as tweets. These users can be represented as nodes. Nodes are these round shaped objects that you see in this picture here. On the other hand, the connection between people can be represented as edges. Edges are basically the straight lines that are drawn from one node to another. Here you can see. Basically, they connect two nodes. Together with these nodes and edges, the social media networks can create a large graphical structure, and we can examine various property of it by looking at it. Now, let's talk about the connections in social media network. When people are in your Facebook friend list, you can see their information and they can also see your information in return. So, when you think about it, information is going from you to them, and on the other hand, information is also coming to you from them. So, in a way, this flow of information is bidirectional, or it is going both ways from you to them and from them to you. These bidirectional connections can be defined by lines without any directional sign, as you can see in the slide. However, in some of the social network connections, information flows only in one direction. For example, in Twitter, when you follow someone, you only see his or her update. As long as the followed person does not follow you back, they won't be able to see most of your updates. Here in this case, after following that person, the information is going only to that person from you, and it is not the vice versa. So there's only one direction. This one directional information flow can be visualized with lines that have a directional edge. We can refer to this connection as unidirectional connection, and it is also showed in the slide. The types of connection that I have talked about so far are only limited to one single social network. For example, the interaction between people in Facebook friend list are only limited in Facebook. The followers in Twitter are only limited to Twitter website. So in this case, it may appear that the information flow is only limited to dedicated social networking site and does not flow from one different social media to another different social media. If this was true, all the information in Facebook would be contained in Facebook. Similarly, all the information in Twitter would be contained in Twitter. However, most of us already probably know by now that this is far from reality. Information can obviously flow from one social media to another. For example, from Facebook to Twitter, or Twitter to Facebook, from Facebook to YouTube, and so on. So, how does this actually happen? There are many of us who use multiple social media networks. Even I have a Facebook account, a Twitter account, and a YouTube account. Therefore, any update that I see on Facebook, I can share that on Twitter, and in this way, I can propagate information from Facebook to Twitter. Here, in this case, I'm working as a bridge node who has accounts on multiple social media websites and can propagate information from one social network to another. In this way, information can flow outside of a social media, and technically, when you think about it, all the all the different social medias are connected by these bridge nodes. Because of these bridge nodes, all the social network create a large interconnected graph together, and this interconnected graph consists of all the users from social media websites. Here in the slide, you can actually see the bridge nodes. The bridge nodes are basically these black people that have accounts on multiple social media sites, I mean. Here you can see three black nodes, and three of them are basically the same person. One has an account on Twitter, uh, and one account is in Facebook, and the other account is in YouTube. And having three accounts in all these different social media, he or she can actually propagate information from one social network to another. All right, let's try to draw a information propagation graph based on some given information. So let's read out the problem first. Abid and Rohan are two friends who are connected on Facebook. Mainly another Facebook member has both Abid and Rohan in her friend list. However, he unfollowed Rohan due to Rohan's excessive meme sharing tendency. Rohan also has a Twitter account where he follows a celebrity called Jack. Rohan and his friend Sharma follows each other on Twitter. Additionally, Sharma follows Millie's Instagram account. Now try to draw an information propagation graph based on the information. So that's the question. Now let's try to draw the graph. Here, let's notice the first line. Abid and Rohan are two friends connected on Facebook. Let me bring up my pen first. Alright. So in this case, Abid and Rohan are two friends connected on Facebook. So there will be an environment for Facebook, right? Facebook has its own social media environment. So let's draw the environment first. So let's say this is the environment for Facebook. I'm writing this as FB or Facebook. And here Abid and Rohan are two friends that are connected. Now I have already discussed how people get connected on Facebook. They get connected via friend list, right? So in this case, Abid and Rohan would be in each other's friend list. And we have already discussed that when people are in each other's friend list, it's a bidirectional connection, right? Because when they are in the friend list, they can see each other's information. Abid should be able to see Rohan's information, and Rohan should be able to see Abid's too. So in Facebook, they should be in a bidirectional connection, which can be defined like this. So A stands for Abid and R stands for Rohan. We have already said that we can define users as nodes, right? So Abid, A is for Abid, that's one node, and R is for Rohan, that's another node. And let's connect them by this bidirectional edge because they can see each other's information and they are connected on Facebook. And let's look at the second statement. In the second statement, it is written that Millie, another Facebook member, have both Abid and Rohan in her friend list. So let's draw a note for Millie because she is another Facebook user. So that's M, and here's a note for her. And she has both Abid and Rohan in her friend list. So with Abid and Rohan, she should have bidirectional connection, right? She should have bidirectional connection with both of them. However, there's a catch. In the next part, it is written that Millie unfollowed Rohan due to his excessive meme sharing. Now, what happens when you unfollow some person in Facebook? When you unfollow someone, you do not see his or her updates, right? Only the unfollowed person should be able to see yours, but you don't see his or her. So in this case, the bidirectional connection is no more, right? There should be an unidirectional connection. So Millie hasn't unfollowed Abid, so the bidirectional connection should maintain with him. So that's the bidirectional connection. On the other hand, since Millie has unfollowed Rohan, Millie should not be able to see Rohan's information. So information will only go from Millie to Rohan, not from Rohan to Millie. So since information is going from Millie to Rohan, we can define this with an arrow. So this is a unidirectional connection now, as Millie has unfollowed Rohan. Okay, so that's the Facebook environment. And let's see the next line. In the next line, it is written that Rohan also has a Twitter account where he follows a celebrity called Jack. So in order to draw Rohan's Twitter node, let's create an environment for Twitter first. So that's the environment for Twitter. Let's say I define it by TW. So that's the environment for Twitter. And Rohan also has a Twitter account. Let's draw the node for Rohan, the user. So this is Rohan's node. Now, if you notice that Rohan has an account on both Facebook and Twitter. So Rohan can transfer some information from Facebook to Twitter, right? So Rohan here is working as a bridge node. We have already discussed about the concept of bridge nodes, right? So when the same user have multiple accounts on different social media websites, that user works as a bridge node, and that user can propagate information from one social media to another different social media. And we can always show the bridge node connection with bidirectional connection, because Rohan can take information from Facebook to Twitter, and he can also take information from his Twitter account to the Facebook account. So he can propagate information in both ways. So this will be a bidirectional connection. Now in Twitter, Rohan follows a celebrity called Jack. Let's create a node for Jack now. So that's the node for Jack. And in when someone follows another person on Twitter, what really happens that the person should be able to see the followed person's information. So since here Rohan has followed Jack, Rohan should be able to see Jack's information. So the information from Jack should flow to Rohan and not the vice versa. As long as Jack does not follow Rohan, Rohan's information would not flow from him to Jack. So here I can draw another one directional line. So information is going from Jack to Rohan because Rohan is only seeing Jack's update since he has followed him. So let's draw this unidirectional line. So here, Jack, information of Jack is going to Rohan. And Rohan and his friend Sharma follows each other on Twitter. Since they are following each other on Twitter, let's draw Sharma's node. And since they are following each other on Twitter, they see each other's information, right? They see each other's updates. So in this case, the connection should be bidirectional, since the information is going from Rohan to Sharma, and also the information is going from Sharma to Rohan. And next line, additionally, Sharma follows Milli's Instagram account. So in order to draw Milli's account, we have to create another environment for Instagram, right? So let's draw an environment for Instagram. Let's draw it as ins, and here's the user Millie. So this is Milli's node for Instagram account, and Sharma follows Milli's Instagram account. Now here's the catch. Now, you cannot follow someone on Instagram without having your own Instagram account, right? So in this case, as Sharma is following Milli's Instagram account, Sharma has his own Instagram account. That makes sense, right? So let's draw a node for Sharma. So that's our Sharma's own Instagram account. And Sharma follows Millie. So since Sharma follows Millie, update from Millie goes to Sharma, right? So the information propagation should be Millie to Sharma. And since Millie has an Instagram account, you can see that she has an account on both Facebook and Instagram. So Millie can easily transfer her information from Facebook to Instagram and vice versa, from Instagram to Facebook too. So we can draw a bidirectional connection here. So that's the bidirectional connection. Millie is working as the bridge node here, who is transferring information from Facebook to Instagram and vice versa. And since Sharma follows Millie, update from Millie goes to Sharma. So that's one unidirectional connection. And here you can notice that Sharma also has account on both Instagram and Twitter. So Sharma can easily transfer information from his Instagram account to Twitter account, and also it's the opposite. He should also be able to transfer information from his Twitter account to Instagram account. So here Sharma is working as a bridge node between Twitter and Instagram. So that's the entire information propagation graph. You can see that both Facebook, Twitter, and Instagram are connected with each other via these bridge nodes. So Millie is the bridge node between Facebook and Instagram. Rohan is the bridge node between Facebook and Twitter. Sharma is the bridge node between Instagram and Twitter. Okay, there are some unidirectional connection, for example, between Millie and Rohan, between Jack and Rohan, and Millie and Sharma. But if you actually notice that Millie does not have any account on Twitter, but one can actually be able to visit Millie's information on Twitter, right? If you think about it, if Sharma sees Millie's update and if Sharma somehow shares it on Twitter, then maybe Rohan will be able to see it too. So information is not really contained in one single social media. It actually propagates from one social media to another. It can propagate from one social media to another because of this bridge nodes. And one thing you have to remember that these bridge nodes are always bidirectional because the bridge nodes are basically the account for the same person, and the information propagates through these bridge nodes. So I hope this graph makes sense to you.